Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the courtyard of the Pentagon for DoD Lab Day, an exposition of top technology from each of the military services as well as the Department of Defense. And we're honored to have with us a repeat guest, at least for me. We've spoken before, Dr. Morley Stone, who is the Chief Technology Officer of the Air Force Research Lab. How awesome is this?
Oh, it's amazing. It's amazing. In fact, when you look across these displays here, the ability to show our people to not only defense leadership, but the other guests that are here, I just find that awesome.
You guys work on such a vast range of technology. I love Ninja, by the way. We're going to do something on Ninja because anything that's named Ninja needs to have a profile of it.
But we're good at acronyms, you know that.
You are, but it's actually cool, stealthy, comes in the middle of the night. So tell us a little bit about what are they're all your children to a degree, right, in the Air Force technology enterprise. But tell me a little bit about what sort of the real highlights here are you from your standpoint that you guys are putting a spotlight on.
So I'll start it by addressing, if you will, the ends of the spectrum. Because what we have on display here are some technologies, I think, that demonstrate how we want to lean forward with some technologies that are at a low TRL, low tech readiness level. So for example, we have a demo down here looking at pushing around liquid metals. I mean, how cool is that? We're pushing around liquid metals to make reconfigurable antennas. And then we have a display down here in which we're really pushing the frontier in neuromorphic computing. So people ask, what's neuromorphic computing? It's building chip architectures that look like the brain. And if you build a chip architecture that works like the brain, it can fundamentally compute things differently than a standard silicon processor design that really hasn't changed in the past 50 years. So that's, if you will, at the lower tech readiness level that we have displayed here. And at the other end, we have examples of, so not only something like Ninja, which is a counter UAS system, but down at the end here we have a robotic snake. Again, how cool is that? Robotic snake that we can actually put up into wings and use that to do inspection of these tight areas that obviously you can't fit a human in. And the more and longer that we use our platforms past their intended usage, having technologies that allow us to get in there and inspect is becoming hugely important.
There's so much, and that's absolutely true, actually, and that's something that we're going to highlight also is if you take a look at that, that's dirty, it's hard work, it's invasive, there's resealing required, so if you can do that without dropping a human being into it, but can figure out to do that along with fluoroscoping and a whole bunch of other technologies you guys use.
And we're also seeing how not only can you use robotic technology, but we have another display down here around wearables. Now, we, like a lot of other labs, are exploring what's coming out of this explosion of wearable technology. But you mate that with things like maintainers, and you can see the synergy there because I want to put a monitor on somebody who's going to be crawling into fuel tanks and cleaning them. I got to know what kind of solvents are they being exposed to, is their health okay, all of those things. So you see this confluence of tech areas that just wasn't there a few years ago.
I talked to a friend of mine coming over to this. He's an old-timer, served in the Pentagon numerous tours. One of the criticisms that he had is, these are great science projects, but there isn't enough coordination among the services, that you'll go and you'll talk to the Navy guys and they're doing the same thing that the Air Force guys are doing, who are doing the same things as the Army guy. You're a Chief Technology Officer, one of the senior technology brains in the Air Force enterprise when it comes, and in DoD. How are you guys coordinating? What's your counter message to folks like that who look at this as a little bit on the redundant side, for example?
Well, I got to tell you, when I hear that, I always kind of bristle. Because a few years ago, the department got really serious about standing up these communities of interest, and we currently have 17 of those communities of interest. By design, those are the forums that allow us to coordinate among the services' different tech areas. So are all of the services working in the autonomy space? Of course they are. But we try and share best practices, share techniques, and then adapt them for the specific domain that our service has to operate in. And so this perception that somehow we're out there doing this work in a vacuum, absolutely false. There's an amazing amount of coordination that goes on among the services.
You mentioned the communities of interest. How has that changed how you guys all fundamentally work together, share information? As somebody who's spent his life in military technology, how is that a step change from where you guys were operating?
Well, I said the degree of coordination is noticeably different, noticeably better. And I have to give a lot of credit to OSD because OSD has maintained a regular battle rhythm, if you will, about how often the COIs are going to meet, and when they do meet, what kind of products they're going to share with the rest of the department. So OSD's been very good about maintaining that structure and keeping that moving forward. One of the things that I thought was really neat about what came out of the COI structure was going back several years, they started these programs, these ARAP programs, and basically what they were was a way of seeding research in an emerging area, but by definition, the research proposals that came in had to be across the services. And so the whole intent here was how do we begin to tie together pockets of expertise that may exist in different laboratories, whether it be a Navy lab, an Air Force lab, or an Army lab, tie those together and synergize those competencies so that the department gets something better than the individual parts.
The last administration put an enormous emphasis on innovation. That was really one of the hallmarks of Dr. Carter. Bob working along very similar lines during his entire tenure as the deputy. If you go back to what Dr. Carter was doing when he was deputy, it was really from the beginning of the administration. Sure. There was kind of a focus on technology. Do you see that focus extending into the administration? Secretary Mattis has said some very positive things about it. Do you notice any change, any acceleration, any sort of textural differences that we're likely to see in the agenda going forward?
Well, I don't see the attention decreasing, and I will continue to see that as a high focus, high priority area. And the reason is simple. And the reason is simple is that DoD's share of that research and development ecosystem continues to shrink while the industrial share of that research ecosystem continues to expand. So we have to be thinking about different ways that we can reach out, if you will, beyond the traditional DoD tech base and find ways to leverage what's happened in industrial R&D. I mean, it is just absolutely exploding. So I don't see that changing. And I would say from an Air Force perspective, what we are seeing now from our current headquarters Air Force leadership is I'd say an amazing focus and attention on science and technology, because they realize, like a lot of senior leaders in the department, that for the past 15 plus years we've really been focused on conflicts right here and now, and of course that drives a lot of the tech base to think about short-term things. But there's this realization that, hey, are we taking our eye off the longer time horizon, or are we taking our eye off the more revolutionary technologies? And so we see a lot of that focus coming from Air Force leadership, and like I said, I don't see that changing.
Are you getting access to the human capital? I mean, that every once in a while there's alarm. Folks look at, for example, the number of science students in the United States. A lot of them are overseas students. They're going back to China, going back to India, Korea, what have you. And there's a concern that the American students are not as good as some of these students, whether at the graduate level or postdoc or doctoral level. Are you getting access to that top talent who are Americans who can pass the sort of stringent security vetting that folks have to go to get into your business?
So it's funny you bring that up. I just had a discussion on this very topic with one of my chief scientists yesterday. And what we really see, it varies from discipline to discipline. So you take an area like material science and engineering, we're getting lots of top quality U.S. students that are just phenomenal, and we have no shortage of applicants in that area, as an example. But obviously, as you start to get into the information sciences, you get the skill sets that are inherent in autonomy, you get the skill sets inherent in machine learning. Of course, there's a premium on that talent, and we are absolutely engaged in, if you will, a bidding war and trying to compete with industry to try and get that talent. But obviously, as you appreciate, we have a hard time competing for salaries against some of that talent that is in this exploding area of machine intelligence.
And let me ask you one last question, because I'm getting the hook. Autonomy and man-machine interface. Yeah. A friend of mine who's an old-timer, a very realistic, even if sometimes macabre, and one of the things we were talking about was some Chinese work in man-machine interfaces, and he said, the fundamental reality is they can grab a guy, plant a bunch of electrodes in his head, and make a man-machine interface that we can't do. What are some of the and that got me to thinking, okay, well, there are all sorts of man-machine interface that are this short of the actual man-machine interface. But what are some of the ethical and other challenges that stuff like that raises? I don't know whether it's true or not. One can imagine a whole bunch of things, given that I suspect the regulations are a little bit different in each country. But are there any sort of ethical, intellectual challenges and potential disadvantages that forces us potentially to have to work through?
Well, I would say from an ethical standpoint, obviously we're not taking people and jamming electrodes in their head like other countries may or may not be doing. But I think more to the point, we're a long way away from having machines that truly can think on their own and have that degree of intelligence. And so right now we're trying to peel back some of the more fundamental issues that are inherent in that teaming, just like with, put in quotes, simple areas like trust. What does it really mean to foster a trusting relationship between a human operator and a machine? And why this starts to become such an important dynamic is that more and more the decision making is going to be taking place on this machine partner. How do I know the validity of those decisions? How did it arrive at that decision? So there are all those kind of, if you will, societal and psychology implications around this teaming dynamic that frankly we've never experienced before as a species. So that's how I would begin to frame that argument. And we just see it with all of these exploding areas. You're seeing it around genetics, you're seeing it around the microbiome, you're seeing it around human-machine teaming. All of these areas are presenting new ethical, legal, societal implications that frankly we haven't had to wrestle with before.
Dr. Stone, thanks so much for your time, and we look forward to staying in touch with you to get more regular updates.
You bet. It was a lot of fun. Thank you.